This diagram highlights the core conflict in distribution software. Digital systems demand perfect data, but the physical logistics generating it are inherently chaotic. This introduces 4 failure points: connectivity drops, location spoofing, untrackable sales, and cash leakage. We can examine how to resolve these exact failures by looking at a specific case study, a medical supplement distribution ERP. This system relies on a tightly integrated technology stack, driven by a Laravel modern backend and a Vue.js or Next.js frontend. We will deconstruct how this architecture neutralizes those 4 physical points of failure to guarantee a pristine financial ledger at the supply chain's end. High-level system design requires strict digital constraints that force physical realities to comply with digital standards. The first point of failure occurs before the product even arrives. A standard purchase order recorded in a foreign currency, like US dollars, does not accurately represent the true cost of goods sold. To establish reality, the ledger must account for supplementary logistics expenses, specifically international freight charges, border release fees, and local taxes. This diagram demonstrates landed cost distribution. Base purchase costs stack with freight, customs, and tax blocks. An algorithm then mathematically divides these macro costs down into the individual boxes on the pallet. Distributing these costs establishes a highly accurate local currency cost for every single unit. During this exact receiving workflow, the system enforces a hard compliance check. It mandates that warehouse staff capture specific batch numbers and expiry dates into the central ledger before the stock is cleared. Securing that batch data immediately allows the system to execute FIFO, first expiring, first out. This ensures strict medical compliance by dictating exactly which physical units warehouse staff must dispatch later. Without algorithmic distribution of these micro-expenses into a single item's profile, a company operates with profit blindness, making an accurate return on investment calculation impossible. Moving to the field logistics module, the physical constraint shifts to connectivity. Delivery drivers operate in geographic zones with unstable 4G signals, rendering standard cloud-based web applications entirely useless. To bypass this constraint, the front-end architecture deploys a progressive web app, built specifically for offline-first capabilities. This setup utilizes IndexedDB, a local browser storage mechanism, to actively cache essential operational data like product catalogs and specific pharmacy credit balances. This diagram illustrates the offline workflow. When a driver loses connection, the generated sales order cannot reach the backend. Instead, the payload routes directly into the local IndexedDB cache. Once connection is restored, a background worker automatically pushes the locally stored payloads to the database. This architecture eliminates data loss and ensures continuous field operations, neutralizing the physical barrier of poor telecom infrastructure. The next field problem is location accountability. Without a way to verify position, drivers can generate false invoices or claim to be at a pharmacy without actually being present. The standard solution, continuous live background GPS tracking, fails under mobile operating system constraints. Devices actively suspend background JavaScript to preserve battery life. The architectural workaround deployed here is event-based geofencing. This diagram shows the trigger mechanism. The device doesn't track a continuous path. When a driver taps Create Invoice, the app pings the geolocation API, attaching precise coordinates to the payload. The system compares the ping against a fixed master coordinate. If the deviation exceeds a set radius, the invoice is flagged. Tying location telemetry strictly to specific transactional events proves physical presence on demand, bypassing mobile browser background restrictions entirely. In the marketing module, the system faces a severe data barrier. The distributor needs to reward doctors for prescribing supplements, but they cannot legally or technically access a retail pharmacy's private point-of-sale data to verify individual patient purchases. Traditional consumer commission tracking is impossible in this blind operating environment. This graph details the B2B proxy commission logic. The system maps a doctor to preferred pharmacies. The direct patient sale is invisible, relying entirely on the highlighted B2B line. Accrual triggers exclusively when the pharmacy places a restocking order. Upon settlement, background queues automatically route funds to the rep and doctor accounts. Creating a proxy metric allows the ERP to automate highly specific marketing payouts within a completely data-blind consumer environment. The final physical risk involves physical cash collection. Field drivers juggle significant amounts of currency while managing multiple pharmacy balances, creating a high probability for accounting errors and lost capital. To secure the cash, the ERP extends strict double-entry ledger enforcement directly to the mobile device. The driver acts as a dynamic financial entity equipped with an internal wallet that tracks their exact cash liability. This digital T-account ledger demonstrates dual transaction mechanics. When a driver records a cash payment on the app, the pharmacy's accounts receivable drops. At that exact second, the driver's internal wallet balance increases inversely to match the newly collected cash. This forces a mandatory office settlement workflow. At the end of the shift, the main administrator executes a physical cash verification against the virtual wallet balance, resetting the driver's ledger to zero and crediting the master account. Pushing a digital ledger to the edge of the network restricts behavior and forces accurate input, rendering end-of-day cash settlement disputes mathematically impossible. This split-screen diagram returns to our original macro operation, showing the stabilized network. The chaotic physical nodes now flow cleanly into a pristine Vue.js P&L dashboard, populating gross profit and net profit fields in real time. The landed cost engine calculations ensure that the incoming gross profit metric is completely accurate. The B2B proxy commission queues and precise expense tracking guarantee the integrity of the net profit metric. This ERP acts as an active behavioral enforcement engine rather than a passive database recording historical events. It dictates field actions through offline caching, event-triggered geofencing, proxy data modeling, and edge ledger operations.